Hey everyone, let's solve one previous question of algorithm. This question was asked in GATE DA 2025, question number 55. Consider a directed graph G equals to VE where V equals to 0, 1, 2 till 100 and E equals to IJ 0 less than J minus I less than equals to 2 for all IJ belongs to V. Suppose the adjacency list of each vertex is in decreasing order of vertex number and depth for search is performed at vertex 0. The number of vertices that will be discovered after vertex 50 is dash and you need to answer in integer. Here the given directed graph have 100 vertices. I cannot draw a graph of 100 vertices in this space, so let me draw a graph of 10 vertices that you can get idea how DFS is running in this type of graph. And there will be directed edge if J minus I less than equals to 2 and greater than 0. So 0 to 2, 2 minus 0, it is 2. 2 is less than equals to 2, so there will be edge between 0 and 2. 0 to 1, 1 minus 0, difference is 1. So there will be edge from 0 to 1. Next, 1 to 2. Yes, 2 minus 1 is 1, there will be edge. 1 to 3, 3 minus 1 is 2, there will be edge. Next, 2 to 3, there will be edge. 2 to 4, there will be edge. 2 to 5, there will be no edge as 5 minus 2, difference is 3. And 3 is greater than 2. So the difference should be less than equals to 2, then only there will be a directed edge. Now 3 to 4, 3 to 5, 4 to 5, 4 to 6, 5 to 6, 5 to 7, 6 to 7, 6 to 8, 7 to 8, 7 to 9, 8 to 9, 8 to 10, 9 to 10. So in these 10 vertices, the edges will be like this. Now the adjacency list will be in decreasing order of vertex number. So for 0, it will be 0, 2, 1. First 2, then 1. For 1, it will be 1, 3, 2. Then for 3, it will be 3, 5, 4. For 4, it will be 4, 6, 5. So first will be the bigger number, then will be smaller number. For every vertex, there are just 2 adjacent, where difference is less than equals to 2. Now, if we'll run the DFS starting from 0, after 0, we'll visit 2. Then from 2, we'll visit 4. Then from 4, we'll visit 6. Then we'll visit 8. Then we'll visit 10. Then after 10, we'll backtrack. Then from 8, we'll visit 9. Then from 8, we'll backtrack. And from 6, we'll visit 7. Then from 6, we'll backtrack. From 4, we'll visit 5. Then from 4, we'll backtrack. From 2, we'll visit 3. Then from 2, we'll backtrack. From 0, we'll visit 1. So this will be the sequence of DFS. 0, 2, 4, 6, 8, 10, then 9, 7, 5, 3, 1. So this is for 10 vertices DFS. Now we'll consider for 100 vertices. In case of 100 vertices, in the same way, we'll visit 0, 2, 4, 6, 8, 10, 12, 14, 16 till 50. The question is asking the number of vertices that will be discovered after 50. So after 50, we'll visit 52, 54, 56 till 100. Then from 100, we'll backtrack to 98. From 98, we'll visit 99. Then we'll backtrack to 96. From 96, we'll visit 97 like this. So 52 till 100, there will be 25. 50 number by 2, 25. Then this is 50. So 25 plus 50, it will be 75. After vertex 50, it will visit 75 numbers. So after 50 till 100, then backtrack and it will go back till 1. So answer will be 75. This is one way we elaborate the DFS. Now another way, 0 till 50, how many number we are visiting? So it will be 26 including 0. If it will be from 1, then it will be 25. But as 0 is given, 0 till 50, it will be 26 number. And the question is asking after 50. So 0 till 50, 26 number it will visit. 0 till 100. How many numbers are there total? Total 101 numbers. From 101 numbers till 50 it is visiting 26. After 50 it will visit 101 minus 26. So 101 minus 26 it is 75. So after 50 it will visit 75 numbers. In that way also you can find answer will be 75. 0 till 50 26 number it is visiting. After 50 it will visit 101 minus 26. 101 is the total number between 0 and 100. 26 that number it already visited before 50. After 50 it will be 101 minus 26, that is 75. This question is easy if you understand the question. If you can analyze the question, easily you can solve this. I already discussed DFS, just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.